Okay, so I started to differentiate implicitly. The derivative of 1 is 0. Then I did product rule, so I have the first times the derivative of the second plus the second times the derivative of the first. So that was the first times the derivative of the second plus the second times the derivative of the first. And then that'll equal secant squared of xy, and then I did the derivative of the inside, which, hey, was the same thing, like the derivative of xy was the same as the derivative of xy, so you notice this piece and this piece are exactly the same, so they cancel, as long as that doesn't equal 0. I should probably go check that that doesn't equal 0 later, but for now, just let them cancel. So I get 1 equals secant squared of xy, so that cancels, left leaves a 1, that cancels, goes away. And then I'm like, well, I'll try again. I'll take the derivative again. So derivative of 0 is 1. Derivative of secant squared, remember this is the same as secant squared. And so chain rule 2 secant of xy to the first times the, times the derivative of the inside, which I forgot, secant xy tangent xy. So I should have had right in there times secant xy tangent xy, because this outer function was 2 times that, and the inner function is the derivative of secant, which is that, and then the derivative of the inner function by chain rule is that again. So this was product rule for that. Okay, so now if this times this times this times this times this equals 0, then one of these must be 0. Well, 2 is never going to be equal to 0. Secant is not going to be equal to 0. Secant is, I don't think it's going to be equal to 0. These guys aren't going to be equal to 0. I'm doing this kind of fast. I haven't proved them, but let's look at when this part equals 0. So when this part equals 0, I have this, and now it's like, hey, I can solve for dy dx now. dy dx will be scoot that guy over, negative y, divide by the x. So this is what I'm getting, and Wolfram alpha confirms it, so I'm going to stop there. It was a little fast. I should have checked these guys potentially equaling 0, but that's the down and dirty. Okay.